Now we are going to work with the binomial model. We're going to build from the problem we did last class. Suppose 20 donors come to the blood drive. What are the mean and standard deviation of the number of universal donors, O negative, among them? What is the probability that there are 2 or 3 donors? Remember, the probability someone has O negative is 6%. So the difference here is that we have 20 donors. So we know how many people are coming to our blood drive. Again, we have to check to see that these are Bernoulli trials. So we have 2 outcomes. Which is a success and a failure. So success is O negative, and a failure is not O negative. So anything else. Our probability is 0.06, and our sample is finite, but 20 is certainly less than 10% of our entire population. So next we're going to define our random variable. Again, let x equal the number of O negative donors or universal donors. Among, it's important here to note that n is going to be our sample size, so among 20 people. To find the mean, this is really asking for our expected value here. We are going to use n times p. So we have 20 people times 0.06, which equals 1.2 donors. So we can expect 1.2 donors to have O negative blood. Standard deviation of our random variable. This time we're going to do NPQ is the square root of that. So we have 20 people times the success rate of 0.06 and a failure of 0.94, all under the square root. And we get a standard deviation of about 1.06. We will interpret that in a minute below. Let's calculate the probability of 2 or 3 successes. That is, x equals 2 or x equals 3. So here we are looking for the probability x equals 2 or x equals 3, which really means we need to find both these probabilities and then add them. The work for this is a little bit more detailed. So when we start with x equals 2, we have 20 people to choose from, and we need to only select 2. So it doesn't matter what 2 are those donors, it could be in any order. So we're going to do 20 to choose 2 times the probability that they are both O negative, and then there are 18 people that don't have O negative. Then for probability that 3 people have it is 20. This time I want to choose 3 people. Doesn't matter who those 3. Could be the first person that walks in, the 17th, the 19th. Doesn't matter. So 3 of them have O negative, and 17 of them do not. Now, if you don't remember how to find 20 choose in your calculator, you're going to hit 20 because we want that first. Then you're going to go to math, scroll over to probability, PRB, go down till you see NCR, hit enter, plug in 2, and you get, once you hit enter again, 190. So really I'm doing 190 times 0.06 squared times 0.94 to the 18th, and I'm going to do it again for the 20 choose 3. When you do this, you should end up with 1,140 for 20 choose 3. That's a lot of different combinations of selecting 3 people. So now let's put it all together and interpret our results. So in a group of 20 people, we can expect to find an average of 1.2 universal donors. About 31% of the time, we have 2 or 3 donors that have O negative. We can also say in here, we can look back at our standard deviation up here and also add that into our sentence down here, that we could expect to find an average of 1.2 or as many as 3 or as few as none every blood drive. again, we can do this on our calculator by going to second vars, choosing this time A or B, and selecting enter. Pay attention to the difference. So there's a P here, and there's a C here. C again standing for cumulative. So we're looking for keywords like on or before or fewer than. So looking up at binomial PDF, we're allowing us to find the probability of any individual outcome. So first example, find the probability the first O-negative donor is the 10th person out of 20. So I'm looking for X to be 10. In my calculator, I'm going to set this up as binomial CDF or PDF. I have 20 people at my blood drive. The probability they'll have O-negative is 0.06, and I want the 10th person. When I plug that into my calculator, I see an E at the end, so I just need to move my decimal over. My final answer here is 706017. So a very small chance that my O-negative donor is the 10th person. So what do we think about if it's the 12th person? Probably pretty small. So again, I'm going to set it up, binomial CD or PDF, and I want 20. Again, probability is 0.06, and it's the 12th person. I get 1.67 times e to the negative 10th, so that means I need to move my decimal over quite a bit. So I'm going to add lots of zeros before. Okay, very small chance. All right, fine. Now's a good time to hit pause. Try the next one. Check your answer with mine. You should get, again, a very small chance that it is the 6th person. Now we are going to calculate the probability of getting X or fewer successes among the N trials. So this is when I'm going to use cumulative. So find the probability of success of getting O-negative donor on or before the 6th person to walk in. So we want on or before the 6th person, so I'm going to set it up like that. And then show that what I'm doing in my calculator, CDF. Again, I have 20 people. Probability is 0.06, and I want it to be the 6th person. When I do that, in my calculator, I get 0.99989. So a pretty near perfect chance that I will have somebody on or before the 6th person. So number 2, find the probability of success of getting O-negative donor on or before the 9th person. Well, if the 6th person was almost perfect, the 9th person is definitely going to be very close to 1. Same with the 12th down here. So we're actually going to change it so it's actually more relevant. Let's try the 4th person here, and we'll make the 2nd person here. So for number 2, let's set it up so we want it on or before the 4th person. So I'm going to repeat what I did up above. Binomial CDF 20. Probability is still the same, and I want it to be the 4th person. And I get 0.9943, so a little bit smaller chance. Find the probability of the before the 2nd, so repeat those steps. We want the 2nd person. 88.5% chance.